Hey guys, hi, hello, namaste, adavas, Sriyakal, assalamu alaikum, vanakkam and khamma khani to all of you. Welcome to today's class, and this is your Vedantu's 9th and 10th English channel, and we are talking about Prodigy Series, and this is for CBSE 10th grade. Alright, so as you all know beta, we are doing the first chapter, real numbers, in which I have done one session in which I have given the introduction of this chapter and revised the topics which we have studied in grade 9. Now, in this session, we will be talking about a very important part of this topic or of this chapter, that is Euclid's division lemma. A very important topic. Like, how can I tell you? It is the most important topic of this chapter. There will be one or two questions in the exam every year. You can go and check the question paper of the previous year. You will find a question definitely from this part. So we'll be studying about Euclid's division lemma and then a small topic of Euclid's division algorithm as well to finding out HCF, a very easy topic. All right, so without wasting any more time, let us start the class. So first thing first, what is Euclid's division lemma? The statement is, given positive integers a and b, understand very carefully, given two positive integers a and b, there exist unique integers q and r satisfying a is equal to bq plus r, where r is greater than or equal to 0 but less than or equal to b, but less than b. Now what I want you all to understand this thing, it is same as the division algorithm which you have learned now. Dividend is equal to divisor into quotient plus remainder. Same thing. What it says, see, if we have two positive integers a and b, if we have two positive integers a and b, so if I divide them, say if I am doing a divided by b, if I am doing a divided by b, then I can say this can be written. Obviously, if I do a divided by b, there will be some quotient, there will be some remainder. So from here we have got a statement that if we have two integers, we can always relate them. We can always make an equation in a and b where q and r will be some number such that a is equal to b into q plus r. A is equal to b into q plus r. Remember, here a, b are positive integers. Positive integers means I am talking about natural number. So a as well as b will be what? Natural number. A as well as b will be natural number. And one more important thing is given over here, that the r is greater than or equal to 0 but less than equal to b. Greater than or equal to 0 but less than b. It is the most important topic or the most important point to understand in Euclid's division lemma, that the values of r will be from 0 till the value of b. So the values of remainder will depend upon the values of b. Say a and b will be natural number. You can pick any natural number you want. We can pick any natural number you want. Remainder's value or the value of r will be equal to either 0 or more than 0, but it has to be less than b. It has to be less than b. So in this equation beta, a is equal to bq plus r. Please understand very carefully. If I write it in the division form, I am dividing a with b. I am dividing a with b. I am getting quotient as q, and after division I am getting remainder as r. For example, let's say if I choose a is equal to 5 and b is equal to 3. So I can say this, if I have to write it in this form, a is equal to bq plus r, divide 5 with 3. So I can say, sir, 3 ones are 3, subtract, remainder is 2. So I can say a, b, q, r. So I can say 5 can be written as 3 into 1 plus 2. So this is how I have related A and B. I have related A and B. Now suppose if I say put the value of A as 7. So 7 divided by 3 if I am doing again. So 3 2s are 6, remainder 1. So 7 I can write it as 3 into 2 plus remainder 1. Alright, so you understood the division lemma, Euclid's division lemma. A is equal to BQ plus R. A will be your dividend, B will be your divisor, Q and R will be your quotient and your remainder. Remember, A and B can be natural numbers, any positive integer. We are only restricting it for positive integers, although it can be extended for negative integers also, but we will not go into that aspect because that time we have to change some values. Alright, so right now we'll be only dealing with the positive integers. Good thing, we'll be dealing with only positive integers or natural numbers. Okay, now I have told you very clearly, A is dividend, B is divisor, Q is quotient, R is remainder. I hope this much part is clear. One question will definitely come in your head, that sir, A and B are natural numbers. Alright, got it. R is greater than or equal to 0 but less than B, where R also must be natural number only. R cannot be 1 by 2, 1 by 3, no, natural number only. R also should be natural number greater than or equal to 0 but less than B. What about Q, sir? What values Q can have? Is Q also natural number only, or is Q also same as greater than or equal to 0 but less than B? Guys, I want you all to tell me the answer in the comment section or in the chat box right now. What do you think the values of Q will be? I'm waiting. What do you think the values of Q are? The values of Q will be natural number only. The values of Q will be same as the values of R, that means greater than or equal to 0 but less than equal to B. What it will be? Alright, what it will be? What? Okay, so dekho beta, understand this thing. Both Q and R, R can be 0 as well, na? So the values of R will be whole numbers, but not all the whole numbers. The whole number which should be less than B. Correct, na? Right? Q is a whole number. Q is a whole number. Alright, what is Q? Q is a whole number. That means Q can be 0 as well. Remember, A and B, we are taking it as positive integers. We are taking them as positive integers. Q can be whole number as well. Alright, Q can be whole number as well. So, for example, let us say 2. Chosen the value of A as 2 and value of B I have chosen as 3. Dekho, 3 one side is becoming 3. No, it is more. So 3 zeros are 0. Remainder is 2. So I can write 2 as 3 into 0 plus 2. So here you can see value of Q is equal to 0. Alright. So I hope you got it. Values of A and B, we are keeping it only natural numbers. Now you may ask me, sir, why cannot I put the value of A as 0? Yes, you can put it, but in this lemma, we are restricting them for positive integers only, because what if I write it as B is equal to AQ plus R? So division by 0 will not be allowed. That is why we keep the values of A and B as natural numbers. Q whole numbers, that means value of Q can be 0 as well. R also whole number but less than B. Greater than or equal to 0 but less than B. This is the most important topic. Alright. So you understood this, that this equation is just a simplified equation made from the division of two numbers. A is equal to BQ plus R. If it is so easy, why the questions are repeated every time? Remember this thing, with this division lemma, we solve different types of question. We get our answer to the different problems where we ask that sum of two even numbers is always an even number. Sum of two odd number is also an even number. So we get the solution, or we can prove these statements with Euclid's division lemma. Now, how do we prove it? Let's prove that later. But first focus on how can I write a number or the numbers in different form through Euclid's division lemma. How can I write numbers in different forms through Euclid's division lemma? Let me take some 5 numbers, say 11, 12, 13, 14 and 15. These are the 5 numbers I have taken and I will represent them in different forms. For example, first we will be choosing the value of B. B value we will be choosing, and the value of A, these will be the values of A for us. In first case, A will be 12, 11, 12, 13, 14 and 15, and we'll look at the values of Q and R. Okay? Alright, so beta, if I choose B as 2, so 11 by 2 if I will do, I will say 2 5s are 10, remainder 1. So 11 I can write as 2 into 5 plus 1. This I can write as 2 into 6 plus remainder is not there, so plus 0 I can write. Remainder is 0. This I can write as 2 into 6 plus 1. This I can write as 2 into 7 plus 1. This I can write as 2 into 7 plus 0. 2 into 7 plus 1. If I choose B equal to 3, 3 3s are 9. Remainder 2, 3 4s are remainder 0, 3 4s are plus remainder 1, 3 4s are plus remainder 2, and then again it will become 3 5s are. Suppose if I choose divisor as 4, so it will be 4 2s are 8 plus remainder 3, that will be 4 3s are plus remainder 0, 4 3s are plus remainder 1, 4 3s are plus remainder 2 and 4 3s are plus remainder 3. Alright, so if you notice beta carefully, the remainder values will keep on repeating them. See here, when the divisor is 2, I know according to Euclid's division lemma, the remainder will be greater than or equal to 0 but less than divisor, which is 2. So the values of remainder we can get either the values of remainder is either 0 or other than greater than 0. What are the other numbers? Other whole numbers? 1, 2 is there but less than 2 it should be. So only 2 values of remainder are possible for B equal to 2. So that is why you can see 1, 0, 1, 0, 1, 0. Remainder will keep on happening like that. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Now continue this. After 15, 16 will be 2 into 8. Plus 0, remainder 0. 17 is 2 into 8 plus 1, remainder 1. So remainder 0, remainder 1. Remainder 0, remainder 1. Remainder 0, remainder 1, and this will keep on happening. This will keep on happening. Let's say for divisor 3. For divisor 3, when the divisor is equal to 3, guys, in this case, I can say the remainder should be greater than or equal to 0 but less than 3. That means remainder can be, sir, either 0, obviously equal to 0 is there, it can be 1 also, it can be 2 also, but it cannot be 3 because it has to be less than 3. And here you can see remainder 0, remainder 1, remainder 2. Then again remainder 0, remainder 1, remainder 2, remainder 0, remainder 1, remainder 2, and will continue. It will continue. Then let's talk about this when divisor we have chosen as 4. Divisor we have chosen as 4. So when the divisor is chosen as 4, the values of remainder will be greater than or equal to 0 but less than 4. So remainder can be 0, 1, 2, 3. Alright, but not 4, it should be less than 4. So here you can see 0, 1, 2, 3. Again 0, 1, 2, 3, 0, 1, 2, 3. And this will keep on happening. This will keep on happening. So I can say that if I fix my divisor, I will get my values of remainders. For example, when I fixed my divisor to be 2, understand this thing which is very important. What I am going to tell you right now is the most important part of this topic. If I fix my divisor as 2, I know the values of remainder can be either 0 or 1. The values of remainder can be either 0 or 1. Values of quotient we don't care. It can be anything. It can be any whole number. Q can be any whole number. In all the cases, Q can be any whole number. We don't care about it. We don't care about the values of Q. I am saying if I fix the divisor, I have got a fixed set of values of R. Now all the numbers, all the natural numbers, 11, 12, 13, 15,000, 10,000, 1 lakh, 10 lakh, anything, I can write in this form. If divisor is 2, all the numbers, I can write it as either 2Q plus 0 or 2Q plus 1. They will definitely come under this category. Value of Q can be any whole number. For example, 12 is coming under this category 2Q plus 0. 13 is coming under this category 2Q plus 1. 14 is coming under 2Q plus 0. 15 is coming under 2Q plus 1. So they are alternate. Similarly, if I choose my divisor to be 3, if I choose my divisor to be 3, I can say the value of my remainder will be either 0 or 1 or 2. So all the numbers, all the natural numbers, I can represent them as either 3 into some quotient Q. 3Q plus 0 is what? 3Q only, or 3Q plus 1 or 3Q plus 2. All the natural numbers will fit into any one of those categories. You give me any number. For example, you give me 78. If you give me 78, divide with 3. 3 2s are 6, remainder 1, 3 8s are 3 6s are 18. Done. Remainder 0. So 78 can be written as 3Q. How? 3 into 26. Understood my point? So Euclid's division lemma in the question is used. Euclid's division lemma in the question is used by choosing the value of the divisor. Very important thing. In the questions, we have to choose the value of divisor. Once we choose the value of divisor, all natural numbers I know will be represented in any one of those forms. If I choose my divisor to be 5, I know my remainder must be less than or equal to 0 but greater than or equal to b. So here in this case it is 5. So all the natural numbers I can write it as first 5 into q, remainder 0. 5 into q, remainder 1. 5 into q, remainder 2. 5 into q, remainder 3. And 5 into q, remainder 4. Remainder 5 it cannot be. So all the numbers will fall under any of these categories, any one of these categories. And suppose I will start with here 0, 1, 2, 3, 4. You see the category. See, 0 falls under this category. 5 into 0 is 0. 5 into 0 plus 1, 2, 3, 4. Again 5 ones are 6, 7, 8, 9. 5 twos are 5 twos are plus 1. 5 twos are plus 2. 14. Again go here 15, 16, 17. You can see now. You got my point. So it will be continued over here everywhere. Alright, so all the natural numbers now can be represented in this form. Now, how do we use this Euclid's division lemma? How do we use this Euclid's division lemma? So it is very important for us to understand that what divisor should be chosen. Alright, one more important thing, beta, when I chose a divisor b as 2, I knew my remainder can be greater than or equal to 0 but less than 2. So I had only two values, either 0 or 1. So I have got two values. One is 2q, other is 2q plus 1. Alright. Remember, 2q means divisible by 2. Because remainder is 0. 2q plus 1, not divisible by 2. Not divisible by 2 because simple here, in this case remainder is not 0, it is equal to 1. So those numbers which are divisible by 2 are called even numbers, and those numbers which are not divisible by 2 are called odd numbers. Alright, suppose out of all these numbers which are written over here, for b equal to 5, only 5q are those numbers which are divisible by 5. If I choose over here, out of these numbers B, only 3q are those numbers which are divisible by 3. Rest are not divisible because there is remainder. There is a non-zero remainder over there. Alright, so whenever I have to prove any number, say I have to prove that 25 is divisible by 5, I can say 25 can be represented in the form of 5q. 5 into 5 plus 0. Right? So it is divisible. But 26 is not divisible because 26 form will be 5 into 5 plus 1. Remainder is there, so it is not divisible. Simple. So also remember the representation of even can be done as 2q and representation of odd numbers can be done as 2q plus 1. Now, suppose if I give you a statement that an even number plus an even number is always what? Is always an even number or is always an odd number, what it can be. So how can we solve this question? Understand this thing. Very easy. What I will say is that's an even number I can write as 2q. So let us say one even number is 2m and the other even number is 2n, where m and n are some whole numbers. Remember I have told you q can be any whole number. We are not bothered with the values of q. Q can be any whole number. Alright. So I can say even number in the form of 2q. So let's say q is m over here, q is n over here. So if I add them, I can take 2 common times of m plus n. Beta, देखो, if I will add one whole number with another whole number, my answer will also be a whole number only. So I can say m plus n is some other whole number, let's say q. So my answer is what? 2q. And 2q means what? Even. So sum of two even numbers is always an even number. Sum of two even number is always an even number. So this is the main logic behind Euclid's division lemma. A is equal to bq plus r, where r is greater than or equal to 0 but less than b. Please remember this thing. R is greater than or equal to 0 but less than b. So upon choosing the value of divisor, that is b, if I fix the value of b, I will get my values of r. If b is 3, remainder can be 0, 1, 2. If b is 4, remainder can be 0, 1, 2, 3. Yes, less than b it should be. Remainder should be greater than or equal to 0 but less than b. So once I have chosen fixed, I will first fix the value of b. Upon fixing the value of b, I will get the values of r. Now all the numbers I can say can be represented with some forms of Euclid's division lemma. So if I choose my b as 5, all the forms can be 5q, 5q plus 1, 5q plus 2, 5q plus 3 and 5q plus 4. Now any natural number you give me or any whole number you give me, it will definitely fall under any one of these categories. Definitely it will fall. No one will go outside this. Alright. So this is how this Euclid's division lemma is used. Now suppose if I want to prove that, suppose the question now is, okay, tell me if I add one odd number plus another odd number, what will be my answer? Odd or even? Don't say sir, I know sir, 5 plus 3 is 8. 8 is even, so answer is even. That is, you have verified. That is verification. When I say 5 plus 3 is becoming equal to 8, so I can say odd number plus odd number is giving me even answers. I hence proved. It is not proved. It is only verification. You have verified. Prove we will do now. Prove we will do now. Ab dekho beta, remember odd number can be written as 2q plus 1. So one odd number I will write as 2m plus 1 and another odd number I will write as 2n plus 1. Alright. If I add these two, I have got 2m plus 2n plus 1 is 2. Take 2 common from the all part. So 2 times of m plus n plus 1. Let's say m and n are whole numbers. So this m plus n plus 1 will be another whole number q. So it is equal to what? 2q, and I know 2q is always an even number. That is why I can say sum of two odd numbers will always be an even number. So this is how we use the Euclid's division lemma in different types of question. Remember, in all questions, first important thing is to choose the divisor. To choose divisor. It is the most important part of the question. What divisor you are going to choose? Once you understood how to choose the divisor, all the questions will be very easy. Will be cakewalk for you all. So this is the whole idea behind Euclid's division lemma. Now coming to the next topic, that is Euclid's division algorithm. Euclid's division algorithm is a very easy method to find out the HCF. It is a technique to find out the HCF, highest common factor. Method is very easy. Let me show you with the help of an example. The example which I want to give you, let's say, is okay, let's say 12 and 42. We'll find out now the HCF, not LCM. We'll find out, let us say, the HCF of 12 and 42. Let us find out the HCF of 12 and 42. So beta, what we need to do is we need to follow the Euclid's division algorithm. Alright, so first let's take the values of A and B over here. Simple hai beta, out of these two values, the bigger value will be your value of A. That means bigger value will be your dividend, and the smaller value use it as divisor. Divide 42 by 12. Divide the bigger value by the smaller value. Now if I do the division, 12 3s are 36. What is remainder, guys? So remainder over here will be 6. Remainder is what? 6. Now let's continue the division again. Let us continue the division again. How to continue? Remember beta. Understand this thing. Remainder in step 1 will become divisor in step 2. So this 6, which is remainder in step 1, will now become divisor in step 2. So it will divide something. And what will be dividend? So remember, divisor, that is the value of B in step 1, will become dividend, or it will be the value of A in step 2. So this 12 now will become the dividend over here. And again do the division. 6 2s are 12. You did the division. The remainder is 0. So this method, this process, you will continue till remainder is 0. Understand, till the remainder is 0, you will continue this process. Till the remainder is 0, you will continue this process. So we have got the remainder 0, stop the process. Stop the process, done. Now what is HCF, guys? So remember, HCF is the divisor of last step of division. What is HCF? HCF is the divisor of the last step of the division. So the last step of the division is what over here? In the last division, the divisor is 6. So 6 will be your HCF. So I can say HCF of 12 and 42 is equal to 6. HCF of 12 and 42 is equal to 6. Easy? Clear? Alright, HCF of 12 and 42 is equal to 6. Let's move to the next question now. Let's do one more question. Let's say this time I tell you to find out the HCF of let's say let's give a big number, 120 and let's say 48. These two numbers are here, 120 and 48. I have to find out the HCF of 120 and 48. So again beta, as you all know, the bigger number will be the dividend or A, the smaller number will become divisor. Alright, now let's do the division. So I can say, sir, 48 twos are 48 2 times will be equal to 96. Subtract it. Okay, remainder is not 0 over here. Clearly we can see remainder is 24. Remainder is 24. Then again in the next step what will happen beta? Now 24 will become divisor and 48 will become our dividend. So 48, 24 twos are again. Okay, so in again second step only we have got our answer. So 40, 24 is our HCF. Let me get some more steps. Okay, so let me change the number. Let's change the number a bit. So the numbers I am going to change will be 45. Let's make it 45. I hope it will go a bit long. Yeah, I think so. It will go a bit long. Alright, so 45. Let's make it 45. So 120 divided by 45. So I can say 45 twos are 90. Twos are 90. Yes, remainder is 30. Remainder is 30. Now again complete the step. Now this 30 will become your divisor and the divisor of the step 1 will become your dividend. Now again I can say 30 ones are 30, 32 is 60. Subtract them. So now we have got 15. Now in this step beta, I can say in second step remainder is still not 0. So continue this step. So now this 15 will be my divisor and the dividend will be the divisor of the previous step. So it will be 30. And then I can say so 15 twos are 30. Remainder is 0. Remainder came 0. Stop the division. Divisor of the last division 15 will be my HCF. So HCF of 120 and 45 is what? 50. As simple as that. So this is your Euclid's division algorithm. Understand? Keep doing the division until the remainder is 0, and once the division is done, remainder becomes divisor and divisor of the previous step will become dividend. This logic, if you understood, whole question is very easy. For example, you can see over here we have done the division of your this 320 and 132 HCF. So 320 divided by 132, 2 times 264, 132 264, 56 is your remainder. 56 became dividend, 132 came over here. Again 56 2s are 112. This time 20 is your remainder. The step is not complete. We have to do division further. This time 56 will become your dividend. 22s are 40. Remainder is 16. 16 now will become the divisor, and the divisor of the previous step will become the dividend now. 16 ones are remainder 4. 4 will become the divisor. 16, the divisor of the previous step will become dividend, and 4 fours are 16. So now remainder is 0. Division is over, and in the last step the divisor will be our HCF. Always. Alright guys. So this is how these questions of Euclid's division algorithm are done. And remember, we only stated for positive integers. Alright. So Euclid's division lemma is used for solving the questions, and there the most important thing is choosing the divisors. Alright. And Euclid's division algorithm is a method. Algorithm is what? A method or a technique to find out the HCF. So it means a technique. And lemma is a proved is something to prove, is a statement to prove a statement. Okay, so lemma is a statement and algorithm is a technique. So technique to find out HCF. Don't be confused over here. Alright, now let's solve some questions. But before I solve some questions, let me tell you about Vedantu's Pro subscription very quickly, as I know all of you already know about it. But those students who are new here, let me tell you about Vedantu's Pro subscription. First thing, at Vedantu's Pro subscription, it is more personalized than what we are doing it here at YouTube. First thing, there will be live online classes. All the classes are going to be live classes filled with quizzes, and students will be from the different parts of the world, so you'll be able to interact with them, learn from them, and they'll also get to learn something from you. The next thing is interactive replay. That means even while watching the recording of a class, you can attend the quizzes even while watching the recording, and you can see your name in the leaderboard. Handwritten notes given by the master teachers. The doubt solving, for doubt solving, we have a separate dedicated teacher to take care of your doubts. Other than that, tests and assignments will be shared with you, all right, and so that you don't have to go for different places, everything at one place you will be getting. Next thing is 5,000 plus micro courses and free crash courses for all of you. No need to pay anything extra. Revision courses and topic specific courses are free of cost. So less is more. You can go to the link mentioned in the description box of this video, as well as in the pinned comment. GPE Pro is your code. Let me quickly show you guys what you need to do. Suppose you came over here. Now in this video, you can see in the description box, subscribe to Vedantu Pro now written over here. Click on this link. Once you click on this link, you will be asked to select your grade. Now in clicking on edit, you can change your grade also, or you can change your board also. I have kept it grade 10 CBSE 2022. Now here we have three plans: Pro Classic, Pro Lite, Pro Plus. Pro Lite is the basic plan which have all the features which I have told you till now. So it has all the features. The next is our Pro Classic. So Pro Classic has one extra feature other than Pro Lite, that is doubt solving on mobile app. That means even after the class, you can attend the if you are solving any question and if you get any doubt, just post it on a doubts app and you will get the explanation for it. The third thing is Pro Plus. So Pro Plus has all the features of Pro Lite plus the extra feature of Pro Classic plus the feature of personal mentor. Personal mentor will be your teacher, your guide, supporter, motivator. Any role, any query you have, academic, non-academic, you can always reach out to them, be it related to Vedantu, be it related to your school, be it related to your studies, anything, they will be there to help you and guide you throughout this journey of grade 10th. Alright, so these are the prices of the course, beta. If you are still having a doubt that online education, I don't know how it is going to be, you can try this course for 1 month. So trying, you can go for anyone. Pro Lite you can try, Pro Plus, Pro Classic you can try, or Pro Plus you can try. Once you have liked that course, then you can go for the subscription for the whole year. And remember, when you are doing complete course, when you are buying the complete course, it is not necessary that you have to pay everything all at once. EMI option is also available. GPE Pro code is already applicable over there to give you 10% off. All right, so let's move ahead now with the questions. First question: using Euclid's algorithm, find the HCF of the following. So beta dekho, see, numbers are big enough, but the questions, the finding HCF questions are not that difficult. Okay, let us say by bigger number divided by smaller number. So 2520 divided by 405. Obviously, if I will divide, I have to multiply it with what? 5 times. So 405 into 5, it will be equal to 2025. 2025. So if I subtract them, I will be getting, if it was 2020, 500, so 495. Wait, is it 495? Okay. Oh, sorry, I have done a mistake. See, when the remainder is more than divisor, that means I have made a mistake. When the remainder is more than divisor, I got to know I have made a mistake. Understand this thing? Alright, so it will be 6 times. 4 6 are 24. 30. 2430. Alright. So if I subtract them, here I can see remainder is 90. Get 405 over here. Divisor of the previous step will become dividend of this step. Now 90, if I will divide it over here, 94s are 360, 95 is 450. So 94s are 360. 94s are 360. If I subtract it, my answer will be 45. Now here 45 will become the divisor, 90 will become the dividend. 45 twos are 90, done. Now you can clearly see beta, the divisor in the last step will be your HCF, as simple as that. So the answer for the first one is 45. Similarly, you can solve it for the second one also. I'll just show you the directly over here. Ab dekho, you must be thinking, sir, how they are writing this form over here. Yeah, writing this form is very easy. Look at this first division. In this division, 1188 is your A. So 1188 I can write as 504 into quotient is 2 plus remainder is 180. Then look at the second division. 504 is the dividend, is equal to divisor into quotient plus remainder. Same thing. So writing in this Euclid's division lemma form is very easy. Alright. So we'll keep doing this division. At the end we are getting 36 as our HCF. Easy question. I think all of you can do this HCF question. Or I am more interested in this question. See what this question is saying. Show that any positive odd integer is of the form 6m plus 1 or 6m plus 3 or 6m plus 5 where m is some integer. Alright. Ab beta dekho, I have to show that all the odd integers, so any odd integer if I will pick, it will be either in the form of 6m plus 1 or it will be in the form of 6m plus 3 or it will be in the form of 6m plus 5. So you can clearly see, looking at this question, tell me, if you can see or not, tell me looking at this question, what should be the value of divisor I should choose for this question? What should be the value of B? What should be my value of B? That is my question. What should be my value of B? See, if you apply the logic clearly, you can see it is 6m plus 1, 6m plus 3, 6m plus 5. So this plus 1, plus 3, plus 5 are your remainders. M is ending a whole number, Q. So divisor is what? 6. So I will choose my divisor as 6. So if I choose my divisor as 6, I know all numbers can be represented as either 6m or 6m plus 1 or 6m plus 2 or 6m plus 3 or 6m plus 4 or 6m plus 5. Why? Only up to 5? Because if B is equal to 6, remainder will be greater than or equal to 0 but less than equal to 6. So the values will be 0, 1, 2, 3, 4 and 5. 0, 1, 2, 3, 4 and 5. So all the numbers I can represent in this form. All the natural numbers will be one form of the other. Will be any one form. So suppose case 1. Case 1. Let's say the number is in the form of 6m. So if it is in the form of 6m beta, I can write 6m as 2 into 3m. And let's say 3m is some other number q. So this number can be written in the form of 2q. So it is an even number. It is an even number. Similarly, case 2. Put a is equal to 6m plus 1. So I can write it as 6m, I can write as 2 into 3m plus 1. Again, if I write 3m as q, I can write it as 2 into q plus 1. And if a is 2q plus 1, I can say it will be an odd number. I can say it will be an odd number. Now, if you must be thinking, sir, why you are writing 6m as 2 into 3m? Beta, since it is asking me any odd number, odd integer or even integer, I know odd or even integer, we write it in the form of 2q or 2q plus 1. 2q being even, 2q plus 1 being odd. I have told you at the starting. Please revise the video. I have told you 2q is even, 2q plus 1 is odd. So I got to know that numbers which are in the form of 6m, they are all even numbers. Numbers in the form of 6m plus 1, they are all odd numbers. Okay? Third one. If a is equal to 6m plus 2. Beta here easily I can take 2 common. So I am left with 3m plus 1. right? So I can write 3m plus 1 as some number q. So a is equal to 2q. That means 6m plus 2 is an even number. Let's go for the next case, case number 4. When a is written as 6m plus 3. A is written as 6m plus 3. Ab beta dekho, you will say, "Arey sir, you cannot take 2 common. Sir, you cannot take 2 common directly. So you cannot take 2 common. तो सर 2q plus 3 है ऐसा लिख देते हैं. No, not like that. See what we'll do. At the end we have to convert it in the form of 2q plus 1. At the end we have to convert it in the form of 2q plus 1. So if you do same thing which you have done in case 2, कि write 6m as 2 into 3m plus 3. So 2 into 3m plus 3 is odd, so I know remainder cannot be more. So what I will do, I will write 6m as 2 into 3m, yes. But since I know in this form remainder can be either 0 or 1 only, in even or odd number form, I will write this 3 as 2 plus 1. I will write this 3 as 2 plus 1. Why? Because I know that now I can take 2 common from this much term. If I take 2 common, from here I am left with 3m, from here I am left with plus 1, and this plus 1, outer one, I am writing it over here. Let's write 3m plus 1 as some number q. So it will be 2q plus 1, and at the end I can say it will be an odd number. It will be an odd number. Fifth one, if I take a as 6m plus 4, so in that case 2 into 3m plus 4 we have. But obviously I can take 2 common, so 2 into 3m plus 2, which is equal to, let's take it as q. So again a is equal to 2q, which is again even. One more case is left, which is 6m plus 5. Okay, so let me show it over here. If a is equal to 6m plus 5, just give me a second. If a is equal to 6m plus 5, write 6m as 2 into 3m, and 5 I can write as 4 plus 1. It is nothing but the previous one plus 1. Previous 6m plus 4 plus 1 is 6m plus 5. So 6m plus 4 plus 1. Ab 6m plus 4 I know is an even number. If I take 2 common, 3m plus 2, and this plus 1 is outside. This, let us write it as q. So it is a is equal to 2q plus 1, which means it is odd. So you can clearly see beta, odd we are getting in case 2 when it is 6m plus 1, and in case 4 when it is 6m plus 3, and in case 6 when it is 6m plus 5. So I can clearly see all the integers which are in the form of 6m plus 1 or 6m plus 3 or 6m plus 5 are odd integers, and rest are even. I have actually done more. I have proved the rest are even also. Alright. So if you have to prove something even, make it a multiple of 2. If you have to prove something is odd, make it multiple of 2 plus 1. 2q plus 1. That is the form you need to focus. Next question. Prove that the product of two consecutive positive integers is divisible by 2. That means if I multiply any two consecutive positive integers, that means say 3 into 2, 3 into 4, 12, divisible by 2. Say 5 into 6, 30, divisible by 2. 11 into 12, divisible by 2. So any two consecutive integers you multiply, they will be divisible by 2. So how do I write two consecutive integers beta? If I take one as x, other will be x plus 1. Yes. So let us say these are my two positive consecutive integer. One is x, other is x plus 1. Alright. So now I have to check that x into x plus 1 is always divisible by 2. Is always divisible by 2. So I have to check whether it is always divisible by 2 or not. Alright. So case 1 beta, what I am taking? Yeah, simple. So case 1, let's say x is an even number. Let's say x is an even number. So this product will become 2q into 2q plus 1. Alright. So now I can write it as, देखो 2q है ना, So 2 into q into 2q plus 1 is there. Yes, now multiplication, and since 2 into something means even, so in case 1 it is even, so it is divisible by 2. Case 2, let's take x as 2q plus 1. By obviously, if I choose my divisor as 2, the values of remainder will be either 0 or 1. So I know all numbers can be represented as either 2q or it can be as 2q plus 1. There is no other choice. So x can be either in the form of 2q or it can be in the form of 2q. So when are 2q plus 1? So I have checked that when x is in the form of 2q, the product is an even number, which means divisible by 2. Now let's check what happens if x is in the form of 2q plus 1. So x into x plus 1. So 2q plus 1, that is x multiplied with x plus 1. So x, that is x only, and we will do plus 1 also. We will do plus 1 also. X plus 1 is there. Na? So that plus 1 also we will be using it over here. So it will be 2q plus 1 into 2q. 1 plus 1 will be 2. Take 2 common from this bracket. So if I take 2 common from this bracket, I am left with 2 into 2q plus 1 into here. If 2 is taken common, q plus 1. So again, if I take it as m, some whole number, obviously if q is some whole number, this whole value is going to be some whole number only. So it is 2m, which is again even. That means divisible by 2. Alright, as I have told you beta, in the starting also, the most important thing is choosing the divisor. I have chosen the divisor as 2, got my answer. Alright, next question. Use Euclid's division lemma to show that cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. Cube of any positive integer. We have to do the cube over here. Now, if you look over here, what is coming into your head? What should be your divisor? What should be your divisor? Huh? Ab dekho beta, if you look at this over here, you will be like, sir, 9. 9 is then 9m, 9m plus 1, 9m plus 8. Huh? Not wrong. You can definitely do this question by taking the divisor as 9. But my point is, if you choose divisor as 9, the values of remainder will be greater than or equal to 0 but less than b. That is less than 9. So remainder can be 0, 1, 2, 3, 4, 5, 6, 7, 8. So these many cases you have to make, then make their cubes, and then you have to convert them in one of these forms. Ab I know that is going to be very time consuming. That is going to be very much time consuming. Yes or no? Yes. But it will give you the answer. You will be able to solve all of them and they will come either in one of the form. But I say, if there is an easier way, let's go for that. What is the easier way? I saw, sir, we are doing the cube over here. So if 9 is coming in the cube, I can say number, can we deal with 3 also? If I choose 3 as a divisor, if I choose 3 as my divisor, my remainder options are very less. I have to deal with only 3 cases, 0, 1 and 2. And if I will do the cube of 3, 3 square is 9. So 9 into 3, 27. So obviously 9 can be taken common. So let's go with this. That is the approach which I have used, a short approach, and let's see whether we will get that or not. So first part, if b is equal to 3, I know all numbers can be represented in the form of either 3q or 3q plus 1 or 3q plus 2. I have told you, once we fix the divisor, all numbers can be represented in their form, division lemma form. So all numbers will be either in the form of 3q or in the form of 3q plus 1 or in the form of 3q plus 2. Now let's see how their cubes are going to look like. So let's say first our number, we have taken our number a as 3q in the form of 3q. So if I do its cube beta, it will be 3q whole cube, which is nothing but 27q cube. 27q cube I can write as 3. देखो अब I want to create 9. I want to create 9. So 27 I can write as 9 threes are. I can write it as 9 threes are. And let's say 3q cube is something m. So it is in the form of 9m. Alright. So if a number is in the form of 3q, its cube will be in the form of 9m. Done. ठीक है sir. Second part. Second, let's go. When the number is in the form of 3q plus 1. So in this case, if I do the cube, it will be 3q plus 1 whole cube. A plus b whole cube. A plus b whole cube will be a cube plus 3a square b plus 3ab square plus b cube. So a cube will be 27 cube plus 3 into a square into b. So 3 into 3q square. So 9q square. 9 3s are 27 into 1. So plus 27q square plus 3ab square. So 3 into 3q into 1 square. So which is plus 3 3s are 9q plus 1 cube, which is 1. A plus b whole cube formula I have used bit over here. A plus b whole cube will be a cube plus 3a square b plus 3ab square plus b cube. Alright. So 3q cube. 3 into 3q square into 1 is 27q square. 3 into 3q into 1 square is 9q plus 1 cube is 1. अब देखो बेटा, from the first three terms, I can take 9 common. I will be left here with 3q cube plus 3q square plus, say I can take q common also, but why to take q only? And then this plus 1 will be separate. This, if I write it as m, now the form is 9m plus 1. So if the number is in the form of 3q plus 1, its cube is in the form of 9m plus 1. Alright, let's look at the last case now. Let us look at the last case, case number 3. When the number is in the form of 3q plus 2. So if the number is in the form of 3q plus 2, let's do the cube. So a cube will be 3q plus 2 whole cube. So again, using this formula, it will be 27q cube plus 3 into 3q square is 9. 3q whole square is 9q square. So 27q square into 2. 27 2s are 54q square plus 3 into 3q. 3 into 3q is 9q into 2 square is 4. 9 4s are plus 34. Sorry, 9 4s are 36 plus 36 cube plus 2 cube is 8. Now better देखो, from the first three terms I can again take 9 common. In 8 I cannot take 9 common. So I am left with over here, I am left here with 3q cube. 9 6 are 6q square. 9 4s are plus 4q. And plus 8 is separate. Let's say there is some point m. So it can be written as 9m plus 8. Alright. So beta, you can clearly see that if my number is in the form of 3q or 3q plus 1 or 3q plus 2, which covers all the types of number, which covers all the numbers, then I can definitely say their cubes, either I am getting in the form of 9m or 9m plus 1 or 9m plus 8. Alright, this is how I have proved this question. Just understand, it is all the game of choosing the divisor. Once we choose the divisor, then it is all about how do you tackle the question. Alright, remember, it is all about choosing the divisor. With divisor 9 also, if you choose divisor as 9, still the question will be correct, but in a 3 marks question you will be writing 5 or 10s of pages, which will not be worth it. See, with taking divisor 3, I have proved also, my answer is also short and sweet. Alright, next question now. The next question is an HCF question in the word problem. So an army contingent of 616 members is to march behind an army band of 32 members in the parade. So 616 members will be marching behind 32 members parade. Two groups are to march in the same number of columns. Number of columns must be same. What is the maximum number of columns they can march? Maximum numbers means what is the maximum number which will divide both. Maximum number dividing both will be HCF. So we have to find out the HCF of 32 and 616. So what we are waiting for? Let us find it out quickly. Alright. So 616 divided by 32, if I will do, I know it will be more than 10, less than 20, and will it be less than 320, 640, 640, 30. 9 side is going sometimes. It is 19 times. 19, 32 into 19 times. 32 into 19 times 640 minus 30, 610, 608. 608. Alright. Subtract them. You have got remainder as 8. Get 32 over here. See, it is over in one step. Sometimes Euclid's division algorithm for the HCF bigger numbers solved very easily. So 8 4s are 32. Remainder is 0. Division over. HCF is what? Divisor of the last step. So maximum columns which they can make will be 8. Simple. 8 columns. So 8 4s are 32. 8 columns they are making, they will get 4 rows, and 660 members also in the form of 8 columns. They'll get some rows over there. Okay, beta. अब this I am giving you as your homework question. This will be your homework question. You have to read this question and tell me what will be the answer for this question in the comment section. Let me know what should be your answer in the comment section below. I'll tell you what will be the answer in the next class. Alright, beta. So this is all from my side in today's class. I hope all of you enjoyed this. Please don't forget Vedantu's Pro subscription link is mentioned in the description box of this video, as well as in the pinned comment. GP Pro is your code to get 10% off, and the prices are comparatively very low now, and there is EMI option also to for the payment of fees, and these are the batch starting dates, so join quickly. Also, please don't forget to like the video if you have understood the concept. See, I have tried to make it in as much detail as possible. Try to start it from the very basic, and I hope you have understood it. If not, please rewatch the video. It is my guarantee that you will definitely understand this. Please don't forget to share it with the other friends so that maximum students can join this community over here, and all of them can get this quality education. And let me know the answer for the homework question in the comment section below. Thank you so much, guys. I'll see you soon. Bye bye. Sayonara, Khuda Hafiz to all of you. Bye bye.